On August 16, 2025, a house-sized asteroid is set to pass Earth at an astonishing speed of over 17,700 miles per hour. The asteroid, designated 2025 PR1, is expected to come within 609,000 miles of our planet. While this may sound like a distant miss, it raises important questions about the risks posed by these space rocks. Could an asteroid like this one cause harm? Should we be worried about the larger asteroid threats out there? In this video, we'll take a deep dive into the science behind asteroids, the real risks they pose to Earth, and how NASA is monitoring them to keep us safe. The asteroid approaching us, 2025 PR1, is estimated to be about 55 feet in diameter. For comparison, this is roughly the size of a two-story house. While this may sound large, it is relatively small compared to some of the other asteroids that NASA keeps an eye on. The asteroid will pass by at a distance of 609,000 miles, which is approximately 2.5 times farther than the Moon's average distance from Earth. This means it is unlikely to pose a direct threat to our planet, but NASA is closely tracking its trajectory. NASA classifies such objects as near-Earth objects, NEOs. These are asteroids or comets whose orbits bring them within 1.3 astronomical units of Earth, or roughly 120 million miles. While most of these objects present no immediate danger, their proximity to Earth means that they need constant monitoring. 2025 PR1 may not be a threat, but its proximity serves as a reminder of the large number of objects in our solar system that are constantly in motion, some of which could one day pose a danger to Earth. When an asteroid impacts Earth, it is not just a simple collision. The energy released by an asteroid is a function of its size, velocity, and composition. A relatively small asteroid like 2025 PR1, if it were to hit Earth, would release energy equivalent to several kilotons of TNT. While this may seem like a major explosion, it's much smaller in scale compared to the energy released by larger asteroids. For instance, an asteroid the size of 2024 YR4, estimated to be about 220 feet across, would release an energy equivalent to hundreds of kilotons of TNT, enough to destroy entire cities and, depending on the location, trigger catastrophic tsunamis if it struck an ocean. In fact, even smaller asteroids measuring 10 to 30 feet can cause significant damage. While most of these objects burn up upon entering Earth's atmosphere, they can create massive fireballs that light up the sky, followed by a sonic boom that can shatter windows and cause fires. One of the most well-known examples of this was the Chelyabinsk meteor of 2013, which exploded over Russia, injuring over 1,500 people and causing widespread property damage. Despite the destruction, it was fortunate that this particular asteroid was small enough that it didn't cause any fatalities or more severe consequences. However, the potential for larger impacts cannot be dismissed. A larger object, such as 2024 YR4, could have much more serious consequences. Its impact could result in massive destruction, fires, and shockwaves that would ripple across entire continents. In extreme cases, asteroid impacts could lead to global cooling by injecting massive amounts of dust into the atmosphere, blocking sunlight and disrupting global weather patterns for years to come. Such events, though rare, highlight the importance of tracking even smaller asteroids that could cause localized damage, or worse, affect entire regions or even the planet. While small asteroids are a frequent occurrence, larger ones pose more significant risks, and their impact would have long-lasting consequences. One of the most well-known asteroids under observation is Bennu, a massive rock measuring about 1,640 feet across. Despite its 1 in 2,700 chance of hitting Earth in 2182, the potential consequences of an impact would be catastrophic. The energy released by such an impact would be equivalent to 100 million tons of TNT, enough to trigger global earthquakes, massive wildfires, and even widespread climate change. The dust and debris ejected into the atmosphere would block sunlight, causing global temperatures to drop by as much as 7 degrees Celsius. This drastic cooling would disrupt photosynthesis, leading to widespread crop failures and a collapse of food systems across the globe. The loss of sunlight would also affect the ability of plants to produce oxygen, further contributing to a global crisis. The effects on rainfall would be equally devastating, with precipitation likely to decrease by 15%, and the ozone layer would suffer significant depletion, leaving Earth vulnerable to harmful ultraviolet radiation. Although Bennu's odds of impacting Earth are low, it illustrates the kinds of risks posed by large asteroids that are constantly monitored by NASA and other space agencies. While the impact scenario is unlikely, the consequences of such an event are severe enough to warrant global attention and action. To counter the threat posed by asteroids, NASA has established the Planetary Defense Coordination Office, which is dedicated to tracking and mitigating the risks of near-Earth objects. Currently, there are over 27,000 known NEOs cataloged by NASA, and that number is only expected to grow as technology improves and more asteroids are detected. Although the vast majority of these objects are not a threat, some larger asteroids like Bennu still pose a risk to Earth in the distant future. To address this issue, NASA has developed several initiatives, including missions to deflect asteroids that may pose a significant threat. One of the most notable projects in this effort was the Double Asteroid Redirection Test, DART, which launched in 2022. The goal of DART was to test the ability to alter the course of an asteroid by deliberately crashing a spacecraft into it. The mission targeted the Didymos asteroid system, where the spacecraft successfully impacted the smaller asteroid, Dimorphos, changing its orbit. This success demonstrates that it is possible to deflect an asteroid on a collision course with Earth, provided there is enough time to prepare. Additionally, NASA is working on advanced telescopes and observatories to identify even more NEOs. The NEO Surveyor mission, for instance, is expected to help NASA find 90% of asteroids larger than 140 meters by 2029. The goal is to give humanity more time to prepare if a dangerous asteroid is detected, allowing for potential deflection missions or other measures to minimize the threat. Asteroids are a constant reminder of the unpredictable nature of space. While many of them pose no immediate danger, the potential for a catastrophic impact is something that humanity must continue to monitor and plan for. With advancements in space technology and international cooperation, we are better equipped than ever to track and potentially prevent asteroid impacts. However, the reality is that we will likely never be able to eliminate the risk entirely. Our efforts must focus on improving detection, developing deflection technologies, and ensuring that we are prepared for whatever the future might bring. As space exploration continues to grow and our understanding of asteroids deepens, it's crucial that we remain vigilant and proactive. The question is not whether we will face an asteroid impact, but when. The tools and strategies we develop today will determine how well we can protect ourselves from the threats of tomorrow. So, is Earth at risk from asteroids like 2025, PR1, or Bennu? For now, no. But as we've seen, the threats posed by space rocks are real, and we must remain vigilant, prepared, and committed to using our growing knowledge and technology to safeguard our planet for future generations.